Okay, so we're going to move on then to the keynote. Sorry, I was confused.
Why you got the microphone?
Not exactly sure what the chairs have to do with the keynote, but so we're going to have a talk from Matt Turk, who is going to tell us some interesting things about software sustainability and science software and what should be sustainable, maybe what shouldn't be sustainable. Other interesting thoughts. So I think from the organizing committee, the reason that we're actually very happy to have Matt be willing to do this is that we're kind of, I would say we kind of have a mix of different people who are kind of, I don't know, faculty or staff who are doing things, people who are telling other people what to do sometimes, people who are working in large collaborative projects. It seems like Matt actually combines a lot of these and really has a very strong hands-on approach and a lot of good experience in using today's tools. And so I think this will be a good opportunity to get a real good sense from a very active practitioner of what's working and what's not working and what we might do better.
So thank you. Is it sufficient? The mic is? Okay. So thank you, Dan, for raising expectations in what I can only assume is going to be an extraordinarily disappointing next 40 minutes. Oh, come on. I'm vulnerable up here, and I'm not getting any anyway. So I changed my title slightly. Originally, it was which software should be sustained or something like that, and I realized that I'm not the person to answer that question, of course. So instead, what I wanted to do is talk about why sustain scientific software and just some of thoughts that I had on this. And I made a vow for myself when I prepared this talk. The first was that I wouldn't directly mention any projects that I work on, and the second would be that I would start over from scratch from all previous talks that I've ever given. And then this morning, I actually read a blog post from somebody that I respect a lot in the open source community about the process that this person went through of being burnt out on community engagement and the toll that took on their personal life. And so I tossed a little bit of that in there as well to talk more on the on the human side, but I encapsulated it in a single parenthetical slide that comes up relatively soon. So I want to start out, though, first with just two caveats. The first of these is that I want to ask, what is this? Does anybody know what this is? What are we looking at here? Stick figure, that's close. Happy user, no. This is a straw person. So a straw person is the notion that, it's a logical fallacy where you build up a straw person, a sham argument essentially, and then you knock that down because a straw person is easy to knock over, right? So I'm going to do some of that today, where I build up sham arguments and then knock them over. But since I'm the one with the lavalier mic, and oh shoot, Dan still has a mic. Anyway, since I'm the one with the lavalier, I suppose it's my prerogative to engage in logical fallacies. And the second one is that this is not original research. In fact, I'm going to be drawing very heavily, and I have a bibliography that I'll put up online, but that's not part of this, but I'm going to draw very heavily on things that I've learned about from the WSSSPE conferences, principally, but also from people researching in socio-technical spaces, inside science, as well as inside open source software. So I want to start out with something that Dan also started out with, but I didn't actually see his slides before I prepared this, which is sort of a recap of where we are. So this is WSSSPE 3, and WSSSPE 1 was at supercomputing in 2013. Has anybody here ever been to supercomputing? Okay, can we see the inverse? Has anybody here not been to supercomputing? Okay, that's good. This is wonderful. So WSSPE 1 was at Supercomputing 13, and in fact, there were a lot of people that came to supercomputing just for WSSPE, right? We had people that were, running interference with the guards to help some of the invited speakers in without, formally paying for the program, and then there were a lot of people that came in just for WSSPE, and I found that particular aspect of WSSPE 1 so fascinating. That there was this big conference, but the draw of the notion of sustainable scientific software went so far beyond the traditional audience of supercomputing that that people came to a conference, and that was 2013. So that was in Denver as well. And it was on a Sunday afternoon, and there were a whole lot of people there. And I was really blown away during the sessions by how impressive the talks were and how everybody was really, really engaged. And then the following year, we had WSSPE 1.1 at SciPy. And this, if I remember correctly, was just me and Dan and I think Andy Terrell that sort of ran WSSPE 1.1, and we got speakers from around the scientific Python community. And for me, and I'm going to talk about this in just a moment, but the difference in the atmosphere of sort of WSSPE itself, there wasn't a lot of difference in the people that were participating in the program, but the surrounding conference, the atmosphere was very, very different, and I found it really refreshing. We had talks from Fernando Perez, Kitty Huff, Perry Greenfield, and I'm forgetting the fourth person. Dan's just as bad as I am for those of you listening along at home because he can't remember either. Oh shoot, he doesn't have a microphone. And we had a fourth talk as well, talking about the scientific Python community and the way that software has been sustained, inside that community. And then at WSSPE 2, at supercomputing, this was a different atmosphere. We had breakout groups, and people were breaking up into small discussion groups and trying to come up with actionable items. And then we followed that up this year with WSSPE 2.1 at SciPy, where I'm just now realizing I wore the same shirt, so I hope none of you were there, where we also did WSSPE in action, where we came up with actionable things that could be done by the people that were in that room. And that brings us here to WSSPE 3, and I'm really, really happy that this isn't at supercomputing. Not that I don't like supercomputing or enjoy supercomputing, the conference, but the idea of having WSSPE outside of the traditional supercomputing environment, I think, really speaks to the fact that the scientific software that we're talking about sustaining comes from many, many different types of inquiry, types of deployment, types of strategies for maintenance, types of users, and perhaps most tellingly, it comes from many, many different ways of measuring the value of a piece of software, right? When we look at sort of the breakdown between, say, the supercomputing and the SciPy sides of things, when I think about the software that gets presented at a conference like supercomputing, which is the International Conference for High Performance Computing, Networking, Storage, and Analysis, versus sort of the software that gets presented at something like scientific computing with Python, I see two very different types of approaches. And this is, again, a straw person, but I think about them from the top down versus the bottom up. And that's really an unfair generalization, but in some ways it can be extrapolated to apply. If you think about the high value pieces of code that run on a supercomputer where you're optimizing in heroic feats to get out every single flop on your architecture, versus the type of software that you might see at SciPy, where someone has a project that they then turn into a platform, a collaborative piece of code, something like that. They approach things from different perspectives, and they bring different types of ideas to the table in that way. In some ways, it's when I think about the software that I see presented at supercomputing versus the software that I see presented at SciPy, I remember, and I can tell from some of the faces in the room that I'm making a lot of enemies, so I need to apologize also. I have to leave this afternoon to go back to a software sustain. Anyway, when I talk to people at supercomputing about the code that they're writing, almost always they talk about how hard it is, right? You talk to people, oh my gosh, exascale is coming. Exascale is coming, and it's going to change everything. And they talk about this, with these faces that just scream out for a hug. And I can't hug all the people at once because of #introvert. So when I talk to people at SciPy, though, I meet people who are talking about, oh my gosh, you know what? There was a development that made me not only able to do something faster in wall clock time, but that helped me do things I couldn't have done before. Like we had a couple people talk about Jupyter, right? And Matthias and Ryan both brought up Jupyter. Well, Ryan's got it on his shirt, so that counts. But I know Matthias works on Jupyter. And you think about the way that a package like that evolves and the way that it touches so many different aspects of the research workflow. You can think about that versus, say, something that I did in my graduate work where I tried to optimize out an ODE solver. And it's not that it's not a value judgment to say that one of them takes a different approach towards increasing productivity than the other, right? And so I'm really happy to see that we're here outside of sort of the preconceptions. So pause for self-reflection. So I also wanted to say that over the course of these different things, I've been at all of these workshops, and actually sort of my trajectory through the research ecosystem has changed over that time, and I'm going to describe some of that with examples. But at WSSPE 1, I was a postdoc that thought he had a lot of interesting things to say, that had all these ideas about sustainability of software. And then as time went on, going to WSSPE 2 at supercomputing, I had just taken on a new job, gone to a university, and I'd had that, what comes with, sort of leaving the echo chamber of late stage postdoc, gotten more than a little bit of dosage of humility, and then coming here and being asked to be the keynote, instead of sort of at the beginning of this trajectory where I thought, oh my gosh, I have all these interesting things to say, I got asked to do the keynote, and I was thinking, oh my gosh, I have to come up with interesting things to say, because I'm talking to a room full of people that have thought about sustainability of software, that have participated in it in subtle and interesting and complicated ways, and I am just so honored to be in front of you for the remaining time that I have. Right. So thank you. But I want to return to sort of the title of my talk, which was Why Sustain Software? And I'm going to present to you some of my arguments for why we might want to, some arguments why we might not want to, but I also want to first break that down into the three components, right? Because there are actually three different things that this talks about right there. You've got why sustain scientific software. And so I'm going to break it down into sustain, scientific software, and then end with why, because I think why is the most interesting. But first we start with sustain, then talk about what exactly scientific software sort of is and what it does for us, and what we are talking about when we talk about sustaining it, which Dan talked a little bit about during his talk when we talked about the when he talked about the different categories of people that might be interested in this. And then I want to end with just talking about why, and I'll give some personal reflections on why I would want to. So sustain. So what does it mean to sustain? So imagine that we have a landscape, not a landscape in the particle physics sense, but a landscape in terms of rolling hills, etc. And imagine that we have a flower on this landscape, which we'll call scientific software. So this is it's probably a straightforward analogy. Everyone knows what the next thing that's going to pop up is, right? It's the sun, right? Because the sun is the source of all life on the planet, right? At all of these different conferences, we've talked about the different things that can sustain scientific software. And oftentimes we'll talk about them in terms of measurables, because we like to measure things. And I'm told that at tenure and promotion, measurables and metrics are really interesting. And I've had grants officers ask me for metrics, and I've had to provide those. But they are measurable. They're things that we can measure and that we can say something about. And they might take the form of citations, right? If we can cite software, that's a 1-bit signal. It doesn't matter if they cite your software to say that it's terrible, as long as it shows up in your H-index, right? Am I right? We can talk about the growth of a community around scientific software. We can talk about the number of people that are using a piece of software to develop their own scientific inquiry. We can talk about the number of contributors, the number of people that are helping each other. We can talk about funding. I mean, that's the ultimate metric, right? How much money are you bringing in? That's something that anyone can look at the bottom line and say, this is something that's valuable. because it gets turned into overhead and so on and so forth. And we can talk about prizes. This works well in hard sciences, right? Like physics, you get the Nobel Prize if you discover that supernovas are accelerating the universe or something. I don't know. That's not my field of astronomy. It's a joke. We can talk about stability of the community around it, the way that it transitions between leaders. We can talk about the way that it continues to serve the needs of a given set of community, the way that it doesn't break the test suite, the way that it continues to work on new architectures. But all of these are really, strictly speaking, are proxies, right? They're proxies for some measure of value. Citations aren't the value in and of themselves. They are the proxy for the value. So when we talk about altmetrics, right? Count the number of stars on GitHub, count the number of retweets, count the number of citations. I guess that's just a regular metric. That's a proxy for the impact that something's having. And I know this isn't news to anybody out there, but this is, it's interesting that we're sort of, working with what we have, and the evidence that we have that we can measure doesn't give us direct insight. It just gives us a proxy of insight. So when we talk about sustainable, I've heard various different definitions tossed around at WSSPE meetings. The one that I like the most is that it keeps up with bug reports, right? Because that implies that implies to me that there's some infinite number of undiscovered bugs that live inside the software, and as long as you can keep up with them, even if you don't add any new features, you remain sustainable. And I love that because I write buggy software. And there are a couple counterexamples to this. I think it's tech that converges to pi and LaTeX that converges to E. Is that right? So so adds on a new digit every time a new release comes out. But then there's another definition of sustainable that I heard, which was adds new features, right? And new features could take on any type of measurement. This could be, adding on the ability to read email from within your CFD code. I mean, that would be a new feature. And if I remember my Jamie Zawinski, that is the ultimate end product of all software. But it doesn't have to be the only measure of sustainability, right? Because sustainability could also be doing the same thing that you've done for a very long time, like tech or LaTeX. But this is a measure of health in a community. Something that I heard very often at supercomputing was that sustainable software is one that works on new architectures. And I can say this because we're not at supercomputing, but I'm really growing weary of hardware vendors making new hardware so that I have to write new software. But that is a measure of sustainability, continuing to work on new architectures. If you write your software in the right way and it continues to run, even if we're now running on ARM and or Phi or whatever, people continuing to be able to learn how to use it. This is a way that we can measure sustainability. If it doesn't just die on the vine, if people continue to come to it, they grow with it, they're able to apply it. And then I remember a couple years ago, someone said when they talk about sustainable software as a funder, sustainable does not necessarily mean what the fundees think, right? This is a measure of sustainability, funding, but that's, again, a proxy. I already said that one. Anyway, something that Greg Wilson said at WSSPE 1.1 was that in his view, sustainable software, Greg was the fourth speaker, in his view, sustainable software was software that continued to give the same results over time. So if you wrote a piece of software in the early 80s, that it could continue to give you the same bitwise results over time. And there were other people that presented this as well. And another measure of sustainability would being able to transition between people. Because at the end of the day, the person that writes the software is probably the most expensive part of the software. And not everyone will do that forever, and so it needs to be able to transition between different people that are supporting it, developing it, using it. And particularly at WSSPE 1, there were several different models that were presented for ensuring sustainability, right? The one that I think is very familiar is this model of the funded piece of software, where you have some external agency that's providing funds to some group that's not necessarily exclusively working on it. that develops a piece of software or keeps it going and provides that out to the scientific community. You can think of a different model, and again, these are all likely, in hybrid between different projects, but the model of the productized piece of software, where you have a piece of software that has grown into something that individuals rely on to the point that research groups or people are willing to support it at some sort of pay rate, right? You might be buying a subscription to be able to use cloud services that deploy a piece of software. You might be purchasing a piece of software. You might be doing something like that. And then the final one, which is the one that personally I am the most conflicted about, is that of the volunteer. This is your traditional, old school, not modern day, open source development. And I want to pose a question, which is productized synonymous with self-sufficient? And I don't think that it is, but I was hoping to discuss this with some people later on. Is this notion that if you produce a product, does that produce scientific software that is sustainable and self-sufficient? It's not necessarily the case that it is. And furthermore, it can also lead to a divergence in interest between the people that are trying to use it and the people that are developing it. And then with the volunteer model, we run into a situation of unpaid labor. I would recommend that you check out Ash Dryden's blog post on the ethics of unpaid labor in the open source software community. It doesn't directly relate to scientific software, but it does relate to it. And it talks about this notion of GitHub as your resume, for instance. And this is an interesting one because this is where a lot of the scientific software that I talked about, which as per my vow mentioned at the beginning, I'm not going to mention directly, this is where much of it comes from. Each of these little rotated pack people is supposed to signify a person's full time, right? And that person is probably funded to work on some scientific project, and then as a part of it, they spend a small amount of their time working on the software that's necessary for it. And if that's in an open source ecosystem, that might get contributed back up. But it's interesting because their ability to participate in that volunteer community is not always the same, is not always aligned with participation in their research projects. So for instance, someone that's running a volunteer software project that develops scientific software might have patches coming in from a graduate student from across the world. That graduate student doesn't necessarily align, the interests of the graduate student and the funder of that graduate student, their PI, their fellowship granting organization or whatever, may not align with the interests of the project as a whole. And that's an interesting dynamic that needs to be navigated by all the participants sort of in that discussion. But it's also not necessarily true that you can rely on unpaid labor, on volunteer time to sustain a piece of software. And this is something that I've run into in projects that I've been on in the past. And it comes down to this notion of the top-down and the bottom-up from a different perspective. The funded versus the grassroots, right? And sometimes things transition between the two, and I think that's one of the more interesting situations. And this I put question marks on, the idea of large scale versus small scale, because I think that that's an interesting and incorrect way to classify these two things. Because a bottom-up model of software development can be just as large scale as a top-down model of software development. But at the same time, we tend to think of them very differently. It's very common for people to think that, oh, that's open source, that's, a bunch of volunteers doing it in their spare time, that must be small scale. Whereas that's also one of the areas that can have one of the greatest pieces of impact across broad communities. Oh yeah, well, no. And so I want the second question that I want to pose is what do we mean by scientific software? And this one is the one that I personally struggle with the most, because when I talk about sustaining scientific software, I always have to ask myself, what exactly are we sustaining, right? Because the obvious answer, of course, is scientific software, right? We're sustaining scientific software. We're sustaining these bits on disk that, are are hanging out, and then you can arrange them in the right way, pass them through memory and the CPU and so on, and then poof, out pops a paper, something like that. But this is, again, just another proxy, right? This is not the Platonic ideal, if I've used that correctly. Really what we're talking about is we're talking about scientific inquiry. And when we put it like this, it sounds really high and mighty, right? Like, oh, we're not talking about scientific software. We're talking about the practice of scientific inquiry. This is the big time, right? But even when we say that, we're actually kind of hiding that, no, we're really talking about conducting inquiry via software. We're not talking about the process of inquiry itself. We're talking about the mechanisms for doing that. And when we get right down to it, when we talk about sustainability, very often we are speaking in proxy terms for specific software, right? And this is something that I find really interesting because I do this. Although now that I've admitted it, I'm sure that everyone else in the audience will deny that they do it as well. But oftentimes when I think about sustainability, I think about how can the projects that I care about, how can the people that work on those projects, how can the science that they do with them, how can that continue to go on? How can we sort of rage against the something light, against our own scientific mortality? See, I promised high and mighty, hoity-toity sounding words. But really, when we talk about sustaining specific software, we are, in fact, talking about sustaining people, our collaborators, ourselves, our students, our postdocs, our mentors, our careers, and the future of our field, right? When we talk about, if all of a sudden one were to imagine that all of the fundamental operating system components that make it possible to do scientific inquiry were suddenly unpersoned and left to go, the first thought through our heads would probably be, how would this impact me, right? This is like the very first thing that happens is when you talk to someone else, you always have to realize that they're sort of thinking, what's in this for me, right? And that's what goes on when we talk about sustainability. Now, this isn't, again, this is a straw person argument. I'm wary of drawing this out too much, but we need to think about the fact that when we talk about sustaining scientific software, we all have we have an invested stake in that as well. And again, that comes down to this top-down versus bottom-up. This notion that you can have anointed, specific software packages that will continue to be sustained at the expense of new bottom-up grassroots development. And so I want to close by talking about some possibilities of why we want to sustain scientific software. And again, at this point, as I'm reflecting on looking out at the audience, I apologize that I have to leave this afternoon because I suspect that some of you will have disagreements with me. But I want to bring up a series of ansatz. And I had to look up the pluralization, so I put that in the bibliography here. Ansatz is a German word, and there was actually considerable disagreement on english.stackexchange.com about how to pluralize the word ansatz. So I just went with the simplest one, although there were compelling arguments that you could stick an umlaut in there or just add on an es at the very end. And I have a series of ansatz about why we would want to sustain, oh geez, Sandra, I guess we'll have words. A series of ansatz about what might motivate sustaining scientific software, right? And the first of these I sort of alluded to earlier, which is this notion of the noble scientist, right? You've got these noble scientists that are fully devoted to pursuing pure inquiry, right? They're probably wearing white lab coats or something, and they sit around and discuss things very formally, very collegially, and they're interested in pursuing the next stage of research, right? But that's not really how science works. There's a lot more to it. There are people involved in science. And so the next obvious answer, why would we want to continue to do this? Why would we want to pursue sustaining scientific software is because it's fun, I mean, it is fun, right? Is there anyone here who doesn't enjoy, well, let's say writing code. It's okay. Okay, yeah, in the back. Okay. What about I mean, the people that I talk to about this have always said that for them, when they work on scientific software, what draws them from one side to the other of dealing with cyber infrastructure versus say writing a paper is that it's a creative thrill, that it's a joy, right? Even when it's going poorly, it is a joy, and it's that is fun. We could also say that it's useful. I mean, it is useful. If all of a sudden LinPack were to evaporate, that would be terrible for the top 500 list. But again, we're not at supercomputing, so we don't have to worry too much about that. It is useful. It has measurable impact on the world when we have pieces of software that are reliable. Last night, Ted Haberman was telling a story about the HDF group's providing of data storage mechanisms for NASA satellites. That goes beyond useful to being essential and necessary. Scientific software that performs reliably, that does what it says on the tin, and that can be relied upon to have its bugs fixed and squashed and potentially utilize new and interesting software architectures is useful. And then I think one thing that doesn't always come up is that it is a craft, right? Constructing pieces of software, developing them, ensuring that they're reliable and that they work is a craft that can be honed, and that craftery, that artisanry is something that is useful and important to us as people. And then something that, and again, I said that because of remember the blog post I referenced earlier, I would talk a little bit about this. Something that I wanted to share is that I work on software oftentimes because it helps me gain a sense of identity. And I think that that's something that, I'm just sharing this with you. I'm not extrapolating it to anyone else, but it's a nice thing, and that can be a motivating factor. So at WSSPE 1.1, one person asked not how can we sustain software, but instead asked when do we end? Greg actually, that person was Greg Wilson. Greg actually put it a little bit more viscerally and said, when is it time for software to die? And I think that's an interesting question that I can feel free to just pose to the audience. But when does software reach its endpoint? How do we know? How do we know that when we are sustaining a package, when we are continuing to ensure that it retains its funding, that we are building a community, that we aren't squashing additional new, interesting, alternate takes on it? Because if we think about scientific software as a marketplace, right, you can think of it as each individual package might be competing for market share. And it's interesting because it's not a strict, anarcho-capitalist marketplace, because there are external bodies. And so without answering that, I don't know that we actually have a way to proceed. So I would actually challenge that the end goal of WSSPE 3 is sort of an enemies list of software packages that but how do we know when it's time to stop sustaining? How do we know when things go? When is it time to move on and try something new? Right? I spent many years writing in Python, but now I'm told that I'm not cool if I'm not using Julia or JavaScript or something. So, I mean, is it time to go? But how do we know how to proceed? How do we know when it's time to move on? And so I wanted to end with a wish list. This is my wish list for WSSPE 3. These are the questions that when I developed this talk that I came up with that I wanted answers to. So I'm just gonna toss them out there. How do we ship a product on time when dealing with a mix of funding models and motivations? And I think this comes up a lot in these hybrid models, right? If you're dealing with a hybrid of productization, of volunteer labor, and of funding agencies, you have deliverables that are possibly different, with different stakes for them from each of those different stakeholders. And how do you manage that? particularly with volunteer projects. It was a little bit over a year ago. Oh, no, wait, well, no, I will tell an anecdote. A little bit over a year ago, we had set a date for delivery of a project that I worked on, right? And this was largely a volunteer project. And I was not going to let that slip. Spoiler alert, it slipped. And I pushed and I pushed, and I was, really adamant that we were going to get it out there, and it actually caused rifts in the community. And if you're watching, Cameron, I'm sorry. He's not watching, so you can laugh. That was a pity laugh. And it caused rifts in the community, but at the same time, it was still something that needed to happen, even though it was a volunteer community. How do we deal with that? How do we deal with having deadlines that need to be put out there when we're relying on potentially unpaid labor? How can we live with ourselves if we're relying on unpaid labor to meet deliverables? How do we know when it's time to move on? How do we know when it's time for a software project to go? I just sort of assume that there's a council somewhere and they send out notices, kind of like on Dead Like Me, but I don't think that's the case. And how can productized software balance its future versus its past? If you have a piece of software that was largely developed to meet a research community's needs, and the sustainability model that they seek out following that is to productize it, to make it something that can be invested in, how can they balance the new needs of their customers, their sustainability model, with the needs of the community that helped them get to that point? I think that's a question that I think a lot of different groups have struggled with, and I'm interested to know what the take from the room is. And then I added this one today. How can we help avoid burnout from people that are sustaining software? Like, one thing that doesn't come up at these meetings all that often is how can we keep it fun for people? I mean, these meetings are fun, don't get me wrong, but are there things that we can do in the way that we structure communities that can help to retain some of the joy for people that are participating in them? And can we reduce systemic bias? So this goes back to the blog post from Ash Dryden, which actually breaks down extremely well the ethics of unpaid labor and how they disproportionately affect underrepresented communities. And I think that this is something that, as we think about the different sustainability models that we can talk about, from those different sustainability models, are there ones that reduce the systemic bias against participants in this ecosystem? So thank you very much. I came in at 38 minutes. I was told to aim for 40, so I guess I'm 2 under par. So thank you, everyone.